All right, today we're diving into a real-life detective story. But this isn't your typical whodunit. In this world, the culprits are completely invisible, the crime scene can be an entire city, and the detectives? Well, they're a very special group of scientists.
It always seems to start with a simple question, right? Something just like this. Picture it. You've got thousands of people out enjoying a city festival, and all of a sudden, dozens, maybe even hundreds start getting sick. How in the world do you find the source? And more importantly, how do you stop it from spreading? Well, that is exactly the mystery we're going to solve today.
Okay, so first things first. Every good detective needs to understand the scene of the crime. So what exactly is an outbreak? I mean, we hear that word thrown around a lot, but in the world of public health, it has a very, very specific meaning. The real key here, the phrase you need to remember, is sudden increase. See, an outbreak isn't just about a few people getting sick. It's about more people getting sick than we would normally expect to see in that specific place during that specific time. It's a sudden, sharp spike that tells us something is wrong. It's the first real sign of trouble. And this is so important because it shows you how things can escalate and fast. Think of an outbreak kind of like a small fire. If you catch it early, you can contain it, no problem. But if that fire starts to spread across a whole region, it becomes an epidemic. And if that fire jumps across oceans to other continents, well, then you're dealing with a full-blown pandemic. It all starts with that one initial localized outbreak.
So, that brings up a good question. How do our disease detectives even get their first clue? How do they know that the number of sick people has officially crossed that critical line from just normal expected cases into an outbreak?
Well, public health officials are constantly, and I mean constantly, collecting data. They're data nerds in the best possible way. They know based on years of information that for a big festival like this one, they can probably expect to see around 5 cases of food poisoning. It's unfortunate, yeah, but it's a statistically predictable number. That's their baseline.
But then, the reports start flooding in, and it's not 5, it's 50. That massive jump from 5 to 50, that's the alarm bell. It's the first real clue that tells investigators, hey, this is not a coincidence. Something very specific is causing this, and they need to figure out what it is, fast. The investigation is officially on. So, once that alarm starts ringing, the real detective work kicks into high gear. The number one goal is to follow the trail of the illness from person to person, going backward in time to find that one common source that connects every single case. And this quote really just nails it. An outbreak is, at its heart, a story of connections. You know, people who ate at the same food stall, went to the same party, or were maybe just in the same room at the same time. The epidemiologist's job is to map out that completely invisible web of contact. So let's just walk through a classic example of how this works. It usually starts with someone often called patient zero. Investigators sit down with them and ask a million questions. Where did you go? What did you eat? Who are you with? They learn the patient ate chili with 5 of their friends. So they track down those friends, and guess what? They also ate the chili, and now they're sick too. Bam! That group of friends is what we call a cluster. And when every single person in that cluster points back to the exact same chili vendor, our detectives have found their source. Finding the source is huge. It's a massive breakthrough, but it doesn't mean the investigation is over. Not even close. Now the question becomes, how do you use that critical piece of information to actually solve the case and stop the spread for good? This work has such a long and successful history. Back in 1976, this mysterious pneumonia-like illness hit an American Legion convention. It was the epidemiologists who figured out it was spreading through the hotel's air conditioning system, which led to brand new regulations for building maintenance. Or in 2011, when listeria was making people sick across multiple states, investigators traced it, with incredible precision, all the way back to contaminated cantaloupes from one single farm. That allowed them to recall the product and literally save lives. But, great detective work isn't just about solving cases that have already happened. It's about preventing future ones from ever starting. And that's where modern epidemiology is heading. It's becoming more and more focused on prediction and prevention. So how on earth do they predict the future? Well, it's all about looking for patterns in the data we have right now. For instance, by analyzing global flight data, they can build computer models that show exactly how quickly a new virus in one city could spread across the entire globe. By tracking tiny little genetic changes in the seasonal flu, they can get a pretty good idea of how severe the next season might be and help prepare the right vaccines. It's all about using data to get ahead of the mystery before it even begins. Now, all of this might seem like some really high-level abstract science, but the work these disease detectives do has a direct impact on our daily lives, often in ways we don't even realize.
So here's the big takeaway. Every time you eat out at a restaurant, every time you pour a glass of water from your tap, you are being protected by this invisible shield. It's the quiet, constant, around-the-clock work of these disease detectives that keeps our communities safe and, honestly, makes modern life possible. If you found this interesting, do me a favor and hit that like button, and make sure you're subscribed so you don't miss our next explainer. And by the way, you can also find the audio version of this over on Apple Podcasts. The link for that is right down in the description. I would genuinely love to hear what you thought in the comments, and please let me know what topics you'd like us to break down next. I'll leave you with one final thought. The work of these disease detectives is more important now than it has ever been, because all the experts agree the next major outbreak isn't a question of if, it's a question of when. So the real question is, knowing everything we know, are we ready for it? Thanks for watching.